Hello everyone, here is another example of adding displacement vectors in 2 dimensions. In this case we've got Bruce and he's walking around a large maze. He recorded his movements as listed below. Find his displacement after he stops moving. So we're going to need an orientation, a scale, vectors and our resultant vector. So I'll put in the orientation first. We've got north, south, east and west. We're going to need a scale, and I think for this particular problem we might go with 1 centimetre equals 10 metres. And we'll begin with our first vector. You'll notice that Bruce is walking around. We've got 1, 2, 3, 4, 5 vectors to draw in. Tail to head, tail to head, tail to head, and then eventually find our resultant vector. So our first vector is 20 metres south. At 1 centimetre equals 10 metres, 20 centimetres must be 2 centimetres. So I'll draw that in first, my first vector. Our second vector is 30 metres west. 30 metres must be done with 3 centimetres because 1 centimetre equals 10 metres, and that's to the west. That's our second vector. Our third vector is going to be 50 metres north, so I'll need 5 centimetres to the north. Tail to head, tail to head, tail to head. Tracking Bruce's movements around the maze. Our fourth vector, this is our third vector, our fourth vector is going to be 30 metres to the east, 3 centimetres on my grid. And my fifth vector is going to be 20 metres to the north. So we've got 2 centimetres to the north. Now I can draw in my resultant vector. And it's going to go in like so, from the tail of my first vector to the head of my final vector. There's our fourth vector, our fifth vector. So the resultant vector, I'm going to go from the tail of my first vector to the head of my final vector. This is my resultant vector. And I can measure it, and I see when I measure it that it is 50 millimetres, it's 5 centimetres long. So my resultant vector is 5 centimetres long, which according to my scale means 50 metres to the north. Now, for us in Year 10, we're learning about displacement diagrams and vector diagrams as an important skill for communicating ideas. With this in mind, our questions and assessments are going to be in the north-south axis, or they're going to be in the east-west axis. You'll not see diagonal vectors being added. We don't want to be testing out your use of Pythagoras' theorem at this stage, but I would point out you don't actually need Pythagoras' theorem to answer a question like this one, or even a question with diagonal vectors, because if you have a good orientation, if you have a good scale, if you use your protractor well, then you can simply measure the length of your resultant vector with your ruler, apply the scale, measure the angle of the vector to the north dimension, and you've got your resultant vector without having to use Pythagoras' theorem at all.